In this video, we look at the integration of various exponential functions. We'll start off with the basic case, which we can see here, which is the integration of e to the 3x. Before we do that, let's remind ourselves of the differentiation process for an exponential function. We can see here if we've got y equals e to the 3x, the derivative is exactly the same function, in other words, e to the 3x, but we multiply by the derivative of the index, which in this case is just 3. So logically, to return to the original function, or to anti-differentiate, we need to divide by the 3. And as usual, we add the constant, which in the case of our original example will be 0. So going back to our original integral, we can see that if we've got the integral of e to the 3x, the antiderivative is e to the 3x divided by 3, which is the derivative of that power. Now that only applies where the index is a linear expression. So we can see here in the general case, if we've got e to the kx or any linear expression, we divide by the derivative of that power when we anti-differentiate. Let's have a look at another example where we're integrating an exponential function multiplied by an algebraic expression. The first thing we should do is recognize that an exponential function is involved and look at the separate parts of that integral. We've done that here by looking at the colors. So we've got the basic value of e to a power, 6x squared plus 4x, all multiplied by 6x plus 2. So first of all, let's reconsider the differentiation process. If we have y equals e to the 6x squared plus 4x, we know that the derivative will contain the basic exponential function again, exactly as it appears in the original function. But then we multiply by the derivative of that power, and that derivative will be 12x plus 4. This process assists us with the integration, because what we should do whenever we're integrating an exponential function with a nonlinear expression as the index is to make sure what we have inside the integration matches the derivative of the power. So for example, in this case, you can see that we've rewritten the integration so that the exponential function is now multiplied by 12x plus 4, which is the derivative of the power. This change does require us to multiply the integration by some constant, which we can see as k at the front of the integral, to ensure that we have equality from one step to the next. In most cases when we're dealing with integrals like this, the constant value becomes apparent just by looking at the expression. We can see here that for 12x plus 4 to be returned as 6x plus 2, we need to divide that expression by 2, or multiply it by 1/2. So the value at the front of the integral, or k, is equal to 1/2 in this instance. We're now ready to perform the integration because we can see that the expression inside the integral is actually the derivative for e to the 6x squared plus 4x. So the solution for the integral is 1/2 multiplied by e to the 6x squared plus 4x plus c. Let's have a look at another example of a similar situation. So we can see here that we've got the integral of e to the x cubed minus 4x multiplied by another expression. What we should do first of all is recognize the different parts to make it easier for us to work through this. So we can see that we have got an exponential expression. Its power is x cubed minus 4x. So ideally what we want to have is that exponential expression multiplied by the derivative of the power. This is where things may take a little bit of time, and it's worth being very careful at this step. So we know that the derivative of x cubed minus 4x is 3x squared minus 4. So what we're going to do is rewrite the expression in the integral in terms of what we want. So we've got e to the x cubed minus 4x multiplied by the derivative of the power, which is 3x squared minus 4. To maintain equality with our original expression, we do need to multiply the new integral by some value k, which is a constant. With a little bit of checking, we can see that k has to be 4, so that 4 multiplied by 3x squared minus 4 is equal to 12x squared minus 16. That's the parts in green inside the integral. So we place a 4 at the front of our integral, and now it's a case of doing the integration process. Now we deliberately wrote the expression inside so that we had the derivative of the power of the exponential term. That means that our antiderivative is simply a case of 4 multiplied by the original exponential function, which is e to the x cubed minus 4x plus a constant c. To summarize this process, if we're asked to do an integration where inside that integration is an exponential to some power, that power being nonlinear, what we want to do is rewrite the expression inside the integral so it's an exponential function multiplied by the derivative of that exponential's index. We then have to make an adjustment by multiplying by some constant at the front of the integral. The integration after that becomes quite straightforward because it's just the constant multiplied by the exponential to the original index plus a constant.